The state of motion of an object is described by its speed and its direction of motion. The state of rest is considered to be state of zero speed. An object may be at rest or in motion. Both are its state of motion. स्टेट ऑफ मोशन यानी कि उसके गति की स्थिति. अगर वो एट रेस्ट है, दैट मीन्स द स्पीड इज ज़ीरो, and it can be also in motion, so v is not zero. Both are state of motion. Does it mean that the application of a force would always result in change of state of motion of the object? Let us find out. A common experience that many a time application of force does not result in the change of state of motion. For example, if there is a very heavy box and if a small child is trying to push it, then even after the application of force, the box will not move. Again, no effect of force is observed when you try to push a wall. So, force may or may not bring state of motion, change in state of motion of object. यानी कि फोर्स जब हम लगाते हैं तो स्टेट ऑफ मोशन बदल भी सकती है और स्टेट ऑफ मोशन ना बदले ऐसा भी हो सकता है. Many a times you only tend to move the object. आप सिर्फ ऑब्जेक्ट को मूव करने की कोशिश करते हो. Force can change the shape of an object. Some situations have been given in column 1 of table 8.2 in which objects are not free to move. Column 2 of the table suggests the manner in which a force can be applied on each object, while column 3 shows diagram of the action. So what do you see here? See, a lump of duff is on the plate. Then pressing it down with the hands. So you are doing the change of shape here. That duff is not in motion. It is only change of shape that is taking place here. Spring fixed to a seat of a bicycle. By sitting on the seat, the spring moves down. So there is change of state because it moves down. At the same time, there is change in shape. It is compressed. As it is cushioned, it will be compressed. A rubber band suspended from a hook or nail fixed on a wall. So by hanging a weight, by pulling its free end, you change its shape, also you bring it down. A plastic or metal scale placed between two bricks. By putting the weight at the center of the scale, the scale is bent, so there is change of shape in the scale and there is motion of the scale in the downward direction. So what do you conclude from the observations made in the table? What happens when you apply a force on an inflated balloon by pressing between your palms? What happens to the shape of the ball of duff when it is rolled to make a chapati? In all these examples, we can see that a force on an object may change its shape. So, what are the effects of force in all? Finally, force क्या क्या कर सकता है? A force make an object move from rest. जो object at rest है उसको move. If you kick a football, the football was at rest, it started moving after application of the force. Force may change the speed of an object when it is moving. If you apply the force in the direction of motion, speed will increase. If you apply the force in the opposite direction of the motion, speed will decrease. Force may change the direction of motion of the object. When you apply the force at an angle to the direction of motion, then the direction of the object will change. Force may bring about change in shape of an object, like the dove we have seen, or inflated balloon we have seen, or a spring. It can bring about a change in shape of an object. Force may cause some of these effects or all of these effects. यानी कि जब आप फुटबॉल को किक करते हो तो फुटबॉल की शेप भी थोड़ी सी बदल जाती है और उसकी स्टेट ऑफ मोशन भी बदल जाती है. सो हियर टू इफेक्ट्स आर टेकिंग प्लेस. वन इज द चेंज इन शेप एंड द अदर इज चेंज इन इट्स स्पीड. तो एक से ज़्यादा इफेक्ट भी हो सकते हैं. While a force may cause one or more of these effects, it is important to remember that none of the actions can take place without the action of a force. This object cannot move by itself, it cannot change speed by itself, it cannot change direction by itself, and it cannot change shape by itself. तो फोर्स के एप्लीकेशन के बिना ना तो ऑब्जेक्ट की स्पीड बदल सकती है, ना तो ऑब्जेक्ट की डायरेक्शन बदल सकती है, ना तो उसकी शेप एंड साइज बदल सकती है. सो दीज आर द इफेक्ट ऑफ फोर्सेस. नाउ व्हाट आर डिफरेंट टाइप ऑफ फोर्सेस दैट वी हैव इन नेचर. वन इज कॉन्टैक्ट फोर्स. सम फोर्सेस कैन बी अप्लाइड only when there is a contact between two interacting objects, like the muscular force. You cannot lift something without holding it. Generally, to apply a force on the object, your body has to be in contact with the object. The contact may also with the help of a stick or piece of paper. So there can be another agent which is transferring your force, but actual physical touch is needed for the application of force. When we push an object like a school bag or lift a bucket of water, where does the force come from? It is caused by the action of your muscles in the body. So such forces are called muscular force, and muscular forces are contact forces because they are applied only when there is a physical contact with the object on which the interaction is made. It is the muscular force that enables us to perform all activities involve movement or bending of our body. In class 7 we have learned that in the process of digestion food gets pushed through the alimentary canal. Could it be a muscular force that does it? We know that our lungs expand and contract while we inhale and exhale during breathing. So these are the examples of application of muscular forces. Animals also use this muscular force when bullocks, horses, donkeys and camels, they pull the carts. They use the muscular force for doing this. Since muscular force can be applied only when it is in direct contact with the object, it is also called a contact force. Similarly, frictional force is also a contact force. Recall some of your experiences. A ball rolling around along the ground gradually slows down and finally comes to rest. So without application of force, speed cannot be changed. ऐसा हमने कहा था. तो क्योंकि बॉल की स्पीड कम हो रही है और वो रुक रहा है, इसका मतलब है when it is rolling on the ground, some force is acting on the ball against the motion of the ball. Such force is called the frictional force. When we stop pedaling a bicycle, it gradually slows down and finally comes to stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. So, ये जो स्पीड में बदलाव आता है, that means the object has gathered some speed, and when the force, applied force, ceases to exist, its speed goes down. The speed goes down because of the opposition force, and this opposition force comes into play because of the two surfaces in contact. When one surface is moving against the other, there is a frictional force acting between the two surfaces, and this frictional force, it reduces the speed of the object. So in all these examples, no force appears to be acting on the objects, yet their speed gradually decreases and comes to rest. What causes the change in their state of motion? Could some force be acting on them? This force is called frictional force. The force responsible for changing the state of motion of object is frictional force. It always acts when two surfaces are in contact and there is a relative motion between them. The force of friction always acts on all moving objects, and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between the two surfaces, like the muscular force, it is also a contact force. So, these are the examples of contact forces. But there are certain forces which are also non-contact forces. For example, the magnetic force. Take a pair of bar magnets, place the longer side of one of the magnet over the round shaped pencil on the wooden roller as shown in the figure. So here you will see that when you bring opposite poles of the magnets near each other, then the magnet kept on the pencils roll towards our magnet in hand. Whereas when the like poles are brought near, then the magnet on the pencil, it moves away from the magnet in our hand. Why does this happen? This happens because of the magnetic force, and we know in case of magnetic forces, like poles repel each other and unlike poles attract each other. So north and south pole will attract each other, north or south pole will repel each other. Now this force doesn't require a physical contact between the magnets. It can act even when the two magnets are kept away from each other at a small distance though, but no physical contact is needed for the application of this force. Why are pencils used here? This is because as we will learn in next chapters, that rolling friction is much less than the sliding friction. If the other magnet was on the ground, then the sliding friction will come into play and the other magnet may not move because the magnetic force will be lesser than the frictional force between the magnet and the ground. But the pencils reduce the friction and hence magnetic force exceeds the frictional force and we can see the magnet is moving. So this magnetic force is a non-contact force. It doesn't require a physical contact between two objects for its action. So like poles of magnet will repel, unlike will attract, and that magnetic force will act without contact. So we can say that the magnetic force is a non-contact force. Similarly, the force exerted by the magnet on the piece of iron is also a non-contact force. Similar to the magnetic forces, there are electrostatic forces. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the pieces from edge of the table with the help of piece of thread. Now hold the other piece of straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. What do you observe? You will see that the hung straw gets attracted towards the straw in our hand. Next, rub the free end of the suspended piece with a sheet of paper. Again, bring the two pieces together. This time you will get repulsion, because we know that the like charges repel each other and unlike charges attract each other. So this is that experiment. This is a hung straw and this is the straw in our hand. When the straws are charged, they acquire like charges and hence they repel each other. And when they are not charged, one of the straw which is charged attracts the other. A straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. This is an example of a charged body. Force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the two bodies are not in physical contact. So, like the magnetic force, electrostatic force is also a non-contact force. Then third non-contact force is gravitational force. You know that a coin or a pen falls to the ground when it slips off your hand. Leaves and fruits fall on the ground. The earth attracts everything towards itself. When the coin is held in your hand, it is at rest. But as soon as it is released, it begins to move in the downward direction. It is clear that the state of motion of coin undergoes a change. Can this happen without a force acting on this? Which force is that? That force is force of gravity. Earth attracts every object towards its center. Water begins to flow towards the ground as soon as we open a tap. Water in the river flows in the downward slope due to the force of gravity. Gravity is not the property of earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object, and this force is known as gravitational force. So like the magnetic and electrostatic force, gravitational force is also a non-contact force.